Okay, we started electricity already, but I will just do a very brief recap for electricity. I started saying that if we're talking about electricity, generally we're either talking about charges, which are electrons specifically, charged bodies, we're talking about charges in motion. We're talking about charged bodies without the charge moving. That's just the charges on the body. We said that is static electricity. Static electricity. Or we can call that electrostatic. That was where we started from. Electrostatic. Either static electricity or what now? Electrostatic. However, if we're talking about charges in motion, then we're talking about current electricity. And that's what I want to talk about today. Current what now? Electricity. Current electricity. I'm talking about current electricity today. I'll just explain some basic concepts and then we'll move on. Alright? The first thing I want to talk about is the quantity of charge. Quantity of charge or quantity of charges. The symbol for that is Q. Quantity of charge. The amount of charge that a body possesses is referred to as what now? The quantity of what? Of charge. And the unit for quantity of charge is Coulomb. Coulomb. Right? The next thing I'm going to talk about is electric current. You do well to write this. You can pause the video and then go over current electricity. Electric current, I mean. The symbol for electric current is I. And the unit, which we have learned from the very beginning, is Ampere. The unit of electric current is what now? Ampere. So what is electric current? Electric current is the rate of flow of charges. The rate of flow of charges. So I can say that current I is what now? Quantity of charge per unit time. Just like we said that what now? That speed is the rate of change of distance. Distance with what? With time. This is not distance. I'm just trying to remind you some things we've done what now in the past. So current is what? Is the rate of flow of charges. The rate of flow of what now? Of charges. And very important to take note of these things. The rate of flow of charges. This is current. Let me try and make this smaller so I can have space. Okay. Alright. So I've said that this is what now? I is equal to Q over T. If I make Q the subject, I'll get that the quantity of charge there is equal to what now? Current times what? Times time. These things are very, very important. They are basics. Alright? Quantity of charge is equal to current times what? Times time. Okay, let me put this aside. I'll come back to that. Alright? The next I want to talk about is potential difference. Potential difference. What is potential difference? Let me take this somewhere. Okay. On this side. Okay. What is potential difference? Another word for potential difference is voltage. Voltage. Potential difference, PD, or what now? Voltage. and the symbol is capital letter V, right? And the unit of voltage is volts. The unit of voltage is volts. Is volts. Alright? So what is potential difference? If I have a circuit, for example, a circuit is a path along which electricity travels. I'll explain that later when I have the time. If I have to move what now? Charges from point A to what? To point B. One way to do it is to create what now? The potential difference. So the potential difference is actually the work done in taking a unit charge from one point to what now? To another. So the potential difference between A and B is the work done in taking a unit charge from A to what now? To B. So I can say that what? That potential difference, that is the voltage now, is going to be work done all over what now? Work done over or work done per unit charge. The work done per unit charge is the potential what now? Potential difference. Work done per unit charge. Let me try something very quickly. So if I tell you that potential difference is equal to work done per unit charge, the work done over charge, it's going to mean that work done is equal to what now? The quantity of charge times what now? Times the potential difference. Note that what? W refers to work done. This already says what now? Quantity of charge. Let me look at that. And then we say that this guy is what now? Is the potential what? Potential difference. Alright? And then you should remember that I can use work done and energy interchangeably. Because energy is the ability to do what now? To do work. So if I'm asking for the energy required, I can say that potential difference is the what now? Energy required to take what? A unit charge from one point to another. So I can also have that energy is equal to what now? Quantity of charge times what? Potential what? Difference. These things are very, very important. If you have a pen and a book, you should just take note of them and write them down somewhere. Very, very, very importantly. Alright? So, but we have said also that we have also said that quantity of charge before now is current times what? Times time. So if work done or energy is equal to what? Quantity of charge times voltage, I can say that what? That work done is the same thing as what? IT times V. You get what I'm saying? Quantity of charge times what now? Times potential difference. Q is equal to IT, so I can have this. And then some textbook will arrange it as this. Some textbook will arrange it as this. Whatever arrangement they make is what now is the same, because multiplication is what's commutative. Anyhow you arrange it, like say that 2 times 3 times 4 is saying that what? 3 times 2 times 4, or saying that 4 times 2 times 3, they're all the same thing. The arrangement is what now? Doesn't really matter. Alright? So but I'm going to hold on to, I prefer this guy. I'm going to use this one. So let me take it back. Writing that W is equal to what now? IV times time. Alright, I'm going to come back to this. I will come back to this much later. This particular formula. Let me go back on it. Okay. Okay. Good. We're back here. Now let's take this off. We've talked about potential difference, work done, and all that. Another thing I was supposed to talk about as regards potential difference. Let me do that quickly, very quickly. For potential difference, is that there are two kinds of potential difference that you should note in a circuit. If I have an electric circuit, let's say I have this, then I have this. Just don't mind what I'm doing for now. This is my resistor, this is the cell, let's say this is the ammeter, and this is the switch or the key. If it is open, it means that current is not what now? It's not flowing through. For example, if you just touch your switch, now the light is on. If I touch the switch now, it will go off because I've opened the pathway. current cannot drop, charges cannot jump from what now? Jump through space. So this one is open. If I close it, I've completed what now? The second. I just want you to understand this, right? Now, the potential difference